Right. Who wants to start us off?
Sorry, I haven't pulled it up quite yet.
That's okay.
I can read.
Okay.
It says for questions 3 through 9, please use the following information. Public opinion poll surveyed a simple random sample of 1,000 voters. Respondents were classified by gender, female or male, and by voting preference, Republican, Democrat, or Independent. The results are presented here. In the set of questions, we will explore the research question: Do men's voting preference differ significantly from women's voting preferences? Use the level of significance of alpha equals 0.05. Which set of hypotheses is appropriate for addressing the research question?
For this one, I got A, H of O, independent, H of A, not independent. What did you guys get?
The O is what? The
null.
And A is the alternative. Okay.
Yeah. Do men's voting preferences differ significantly from women's voting preferences? I agree with A.
I agree.
Okay, so 3 is A.
I was just reading through it. Yep.
Okay. Number 4.
I can read number 4. It says, what is the equation for computing the degrees of freedom? And it would be C.
Yeah, that's what I got too.
Okay. Number of rows minus 1 times the number of columns minus 1.
So this is the third one. Yeah. C.
I read number 5. What is the correct choice for degrees of freedom for the problem? I got 2.
So there's 3 minus 1, 2 times 1. Yeah, 2.
Someone's mic is doing something funny.
So wait, so you take 3 minus 1, or sorry, 4 minus 1, so you get 3, and then 3 minus 1, you get 2.
You were right with 3 minus 1. Because you're not taking the total into consideration, just the Republican, Democrat, and Independent.
Oh, so doing into the total. Okay, so it's just 3 minus 1 and 2 minus 1. So,
Yep, and then you multiply them.
Into the totals. Number 6 says, are the requirements for conducting a x-squared test for independence met by this data set?
So there are 6 things that have to be met, right?
So
I think there's only 2.
One of
it
them
says
has
that the expected results have to be greater than or equal to 5, which they are, and then it has to be from a simple random sample.
Of a single population.
Right.
Yeah.
So let's see.
I have a question. What does it mean by the expected count? Is that just, I mean, on the spreadsheet it shows an expected count. Is that what it's asking about, or is it something we calculate on our own?
I think it calculates it for you there. So in each column there's an expected number.
Yeah, I saw that. I just wasn't sure if that was where we were supposed to pull that from.
I think so. So here's the weird thing is that the option that I would expect to see the answer isn't on there because it says, I'd have to pull up the reading.
So isn't it observed count minus expected count squared divided by expected count? You get x squared?
I don't know the equation. I just put it in
I'm not sure of the equation.
You're just using Excel?
Yeah.
Okay.
I could find it real quick though.
Yeah, I'm not sure on this one.
I would guess D, but I don't really know. I don't.
Yeah. Because that is definitely true because
But it's not a requirement, right?
it is a requirement. It's the two requirements. Well, the second one is each expected count must be greater than or equal to 5. I don't know what
Oh,
it's.
I see what you mean. Okay, yeah. So it would be D because all of them,
No.
like in column 1, row 1, there's an expected count of 270. So that's
Yeah.
greater than, and then if you go down the list, they're all greater than or equal to 5.
Yeah. Jason, do you have that? It sounds like you don't have that pulled up in Excel.
Oh, the spreadsheet is what we're using, Jason. Yeah.
Yeah. Do you want me to share my screen so you can see?
Yeah, I can't see it, so because yeah. Let me get on.
Okay. I'm screen sharing. It's really nice. You just kind of punch in the numbers super quick. And then see right here, it says expected.
Okay.
And then it's 270, 270, 60, 180, 180, and 40 across the board. So each of those are greater than 40 expected.
That's helpful.
Okay. So are we all good? Move on to number 7.
Yeah, let's do it.
Okay, 7. What is the value of x squared? Test or the test statistic for the problem. I got 16.2.
And you just got that from using that.
Yeah, just on
Yeah, 16.20 for 2
that.
decimal
Oh, yeah,
places.
20.
And then the p-value is 0.000.
Yeah.
Is that what
You
you're
still have
getting?
to have a leading zero though, so you gotta give 0.000.
Yeah.
Yeah. If we were going 4 decimals, you'd add a 3 to it, but we're just doing 3.
So it's obviously, the p-value is obviously less than the level of significance, which means
Reject the null.
that we reject the null, right?
Sufficient to reject the null, right?
Yep.
Yeah,
Yep.
is sufficient evidence.
So it would be
I put A.
A, yeah.
Yeah. Sweet. Now we got a new data set.
What did you say? The data set?
We just got a new one now for numbers 10 through 14.
Yeah.
It basically says, I click on the link below. Open up the download data for questions. Oh, so we actually have to open up this factors.
Yeah, I looked at that. I opened it up, and it's the exact same as what's already there. So just use what's already there, so you don't have to
What
open
the heck? All right, well, that was a waste of a download. The research questions for this study is, do people in Europe, Australia, and the United States seek chiropractic care for the same reasons? Usually a level of significance of 0.05, and the hypothesis for the study are the null is location and the motivation to visit chiropractic are independent, and the alternative is that they're not independent, so they're dependent. The conditions for conducting a chi-square test for independence are satisfied.
Yes.
Yeah.
Plug it in the data, yeah, you get the expected values are more than 5.
Right.
Cool.
And then, what is the correct choice for the degrees of freedom? We would do 4 minus 1 is 5 minus 4. 4 times 2 is 8.
8, yep.
Wait, you're doing degrees of freedom?
Yeah.
I believe it's 12.
The spreadsheet is giving me 8 as an answer.
Spreadsheet's giving me 12. Maybe I punched in the data wrong.
So 62, 84, 85, 61, 70, 97.
Oh, I did totals. I added totals in the list.
Yeah.
Oh, okay.
Okay, so I screwed up.
That was the same thing I did last time.
And the statistic comes out to be 7.44.
Yeah, that's what I got.
I think is what
What
you guys are
are you
getting.
talking about?
Number 12. So number 11 is 8. Number 12, if you punch these into the chi-square test spreadsheet,
Did you?
it gives
What,
you a
are you still?
statistic of 7.44.
Do you have it punched in, Kelly?
Yeah, I've got it punched in. I'm getting the same numbers.
Okay.
It's right easy right here.
Okay.
All right, and the p-value spat out was 0.490.
Yes.
So it's say 12 again. I thought someone said 7.44.
Right, I was saying 13. Sorry.
13.
13 is 0.490.
Yeah. No, number 12 is 7.44.
Okay, good.
Yeah.
And then, so since we're gonna be bigger than the level of significance, we would say that there is insufficient evidence.
Yeah, so C.
Yeah.
Yeah, see.
0.490. Let's double check on that p-value. You guys got 0.490, correct?
Yes, sir.
Okay.
Yeah.
Well, that was quick. Let's see how we did.
Dang.
Perfect.
100.
Ballers.
Yeah.
I mean, with that spreadsheet, that's really all you need. So.
Yeah, it's pretty straightforward, isn't it?
All it is understanding how to run the system.
Yeah.
All right, great job tonight, guys. I like these fast ones. They're
I know. Sweet.
Yeah.
all right. Well, we'll see you guys on Tuesday.
Okay, sounds good. Thanks, man.
Yep, good night.
Bye.
Good night.